Good morning. Good morning, students. Okay. So we were talking about structure of atom, right? So we were talking about this particular topic. Now, what we were discussing? Anyone? What we were discussing in this topic yesterday? Hmm? Anyone? What we were discussing in yesterday's class in this topic? Okay. So we were actually solving the problems, right? So we were solving the problems. Yes, Savita. Absolutely correct. We were solving some of the problems. So related to frequency, wavelength, and we had started with hydrogen spectra also. We had started with the hydrogen spectra also. Any doubts with regard to those problems? We have done some problems related to energy. Yes, all of you right. So any doubts in those solving those problems? So if you don't have any doubt, so in that case, shall we move to the next one? That means we are going to solve another one related to hydrogen spectra. Okay. So that means all of you can write it down. Calculate the frequency. Okay. So frequency and wavelength. Frequency and wavelength of a photon. Which is emitted due to transition of electron from energy level 5 to 1, from energy level 5 to 1 in the hydrogen atom. Fine. So this is what the question is. Okay. So what is that? Calculate the frequency and wavelength of a photon which is emitted due to transition of electron from energy level 5 to 1 in the hydrogen atom. Fine. So can any one of you solve this one? Yes. So this is the question. So calculate the frequency. You have to calculate two things. One is frequency and one is wavelength, as yesterday's problem. Okay. So now only thing here is we have to mention, or we are going to discuss about the emission spectra. It's not absorption spectra, right? So yesterday we have discussed about absorption. We have solved one problem related to absorption. This is emission. So Manjunath, sir, Piffand and Lyman. Oh, you have written Lyman. So what do you mean by that? Two regions, it cannot be related, na? It should be Lyman series. It should be Lyman series because energy level 1 is involved. It should be Lyman series. Energy level 1 is involved. Anyway, they have not asked about which particular series, but we will mention it. Okay? So we will mention it. It belongs to Lyman series. Can any one of you tell me the answer? So it belongs to Lyman series. I am giving some time so that you people can solve this one. Come fast, fast. Still students are coming fast. Okay. So this is the problem. All of you have started solving the problem. Now I will start writing slowly. Okay. So that whoever is solving, they can be ahead of me. So the answer, we are going to find the solution. Okay. Now, since transition is from energy level 5 to 1. Energy level 5 to 1. Since energy level 1 is involved, so therefore it should belongs to, or it belongs to Lyman series. It belongs to Lyman series. Okay. Now in Lyman series, which is the electromagnetic spectral region? Which is that electromagnetic spectral region Lyman series belongs to? In electromagnetic spectrum, which region it belongs to? Whether visible, UV, X-rays, gamma rays, radio waves, where it belongs to? Lyman series. Any one of you? Okay. So now this particular point is not required to answer, but anyway, if you write, no issue, but you should write proper one. Yes, Chidwan. So it belongs to UV region. If you see that table, you will get the answer. It belongs to UV region in electromagnetic spectrum. Okay. So Stephen, it should be UV, ultraviolet. Okay. So that's where transition is from 5 to 1. So it should belongs to Lyman series. That means ultraviolet region or UV region. Okay. So all of you have understood. So that's where we have the first point. Now once again I will tell. They have not mentioned which series or which region of electromagnetic spectrum it belongs to. They have not asked. So first sentence, it is not compulsory. You can directly solve the problem. Okay. So now that's where we have 1 point. Next one. What is Ni here? Ni is 5 because initial energy level is 5. From 5 to 1 it is moving electron. So therefore Ni is equal to 5. Nf is equal to 1. Nf is equal to 1. So we will apply the equation. That means delta E is equal to RH multiplied by 1 by Ni square minus 1 by Nf square joule. Right? So this is where we have the equation. Equation you have to write. Not directly substituting the value. First, a general equation has to be there because it will fetch the marks. Okay? So then you should substitute these values into that. So therefore, delta E is equal to RH value. What is that RH value? So that is 2.18 into 10 to the power of minus 18. Okay? So divided by, okay, joule here only I will write. So joule, 10 to the power of minus 18 joule. So what is that? Sir, answer will centimeter in negative. Yes, answer should be negative, absolutely correct. Because we are dealing with the emission spectra, it should be negative. Very good. So now 1 by Ni square is 5. So 5 square minus Nf 1 square, right? So that's what I have substituted the value, because Ni is equal to 5. So that's what I have substituted. Nf is equal to 1. So that's what I have substituted. Joule, here only I have written, okay, along with the Rydberg's constant. Okay, so Rydberg's constant is 2.18 into 10 to the power of minus 18 joule. Okay, now delta E is equal to 2.18 into 10 to the power of minus 18 joule divided by 1 by 25 divided by 1 divided by 1, right? Now we can write this one as 2.18 into 10 to the power of minus 18 joule. So 2.18 into 10 to the power of minus 18 joule multiplied by 0.04 minus 1. 0.04 minus 1, because 1 by 25 is nothing but 0.04 or 0.04. Okay, that's what I have written. So 0.04 into minus 1, not into minus 1. All of you have understood? So next we have to solve it. So that is 2.18. Okay, I will write this side only. Okay, so I will write this side only. So therefore from there I am writing, so delta E is equal to 2.18 into 10 to the power of minus 18 joule multiplied by minus 0. So how much it will be? Minus 0.96. 0.96 it will be minus, because 1 is greater than 0.04. So it will become minus 0.96. Since it is an emission spectra, it has to be minus. So if I solve it further, so delta E value or E value will become minus 2.093 into 10 to the power of minus 18 joule. Okay, so since it is emission spectra, it should be negative value. Okay, Ullas, 0.0872. How come? So 2.18 into 0.96 you have to do. Okay, that is fine. 2.0928. Yes, I have made it round figure. 928. Therefore, I have made it as 93. 28 I have made it as 3. Okay. So minus 2.093 into 10 to the power of minus 18 joule. All of you have understood? Any doubt? Ullas, have you corrected? So it should be this one. Answer should be with negative value. So why it should be with negative value? That is because we are dealing with the emission spectra, because from higher energy level it is coming to the lower energy level. So it should be an emission spectra. Okay. So Hagadra, shall I remove this? So this is where we have got the, not final answer it is, this is where we have got the energy. Okay, this is what we have got the energy. How much or what is the energy of those emitted radiation? Okay, so that's what we have got. Okay, so next one. What we have to find? We have to find the frequency. We have to find the frequency. Which equation we are going to use? Anyone? Which equation we are going to use? We have found energy of that particular emitted radiation. Now we have to find frequency and wavelength. So first we will find the frequency. How to find the frequency? Any one of you? How to find the frequency Ah, very good, very good. So that's where we have the E is equal to h nu equation. So by rearranging this equation, nu is equal to E by h. Nu is equal to E by h. So E value just now we have got. So how much that? 2.093. No need to take the negative value. So okay, fine. I will make it clear. So no need to take the negative value. So that negative indicates it is an emission spectra. That's it. Just take that value without any sign. Okay. So if E value is positive, that indicates that it is absorption spectrum. E value, if it is negative, it indicates that it is emission spectrum. But further calculation, don't take the negative value. Okay. So 2.093 into 10 to the power of minus 18 joule. 10 to the power of minus 18 joule. So what is that H value, Planck's constant? 6.626 into 10 to the power of minus 34 joule second. Once again I will tell, energy negative indicates that it is getting released, that's all. Okay, energy positive, it indicates that it is getting utilized. Otherwise energy cannot be negative, right? So therefore don't put the negative value over here. So many students they will do, don't put the negative value. So for further calculation we should take only that value, not with say sign, positive or negative sign. So positive indicates absorption, that is utilization of energy. Negative means there will be release of energy. In this case it is related to emission. Okay, don't get confused. Keep these things in your mind. So when you are calculating for absorption spectra, you will not find this issue. But when your problem is given to related to emission spectra, then you should be knowing this. Okay, so that's where we have the answer as joule. Joule will get cancelled. The answer will be per second, that is 0.315 into 10 to the power of 16 per second. 10 to the power of 16 per second, or you can mention the same answer as 0.315 into 10 to the power of 16 hertz. Anything is fine. So that's why we have the frequency. It can be written in terms of hertz or it can be written in terms of per second. Anything is fine. So that's why we have calculated the frequency. So what else we have to do? We have to calculate wavelength. We have to calculate the wavelength. So can any one of you can tell me how to calculate wavelength? Which equation I should use? We have calculated frequency. What is that frequency? 0.315 into 10 to the power of 60 per second. Okay, or hertz. C by nu. Yes, Pooja, very good. So lambda is equal to C by nu. That's what we have the equation. Okay, what is C? Speed of light. So therefore lambda is equal to 3 into 10 to the power of 8 meter per second. Okay, meter per second. So meter per second, like this I can write, or I can write like this, one and all same. Okay, so to the power of minus 1 means it is divided by only. Okay, that's where meter per second. All of you have understood? So now in the denominator we should have the frequency. So we will take it in form of per second because we have per second here. So 0.315 into 10 to the power of 16 per second. 10 to the power of 16 per second. Right? Now per second will get cancelled. The answer will be in terms of meter. The answer will be in terms of meter because wavelength unit is meter, or it can be expressed in smaller unit called as centimeter, or further it can be reduced to smaller unit called as nanometer. All of them, they are the smaller unit of meter only. Okay. So therefore wavelength will be equal to, what is that answer you people have got? Anyone you have solved? So 3 divided by 0.315 you have to do. Okay. So 10 to the power of 16, if I take it on the top, it will become 10 to the power of minus 16. So minus 16 and 8. So it will be minus 8. Okay, someone has written. Yes, absolutely correct. 9.523 into 10 to the power of minus 8 meter. So that is the wavelength. That is the wavelength. Please remember, you can stop here. This is with regard to wavelength. So therefore, frequency is 0.315 into 10 to the power of 16 per second. Wavelength is 9.523 into 10 to the power of minus 8 meter. Okay. Now, if by chance, if they have asked in terms of nanometer, because wavelength normally expressed in terms of nanometer. But otherwise you can stop here. Please, once again I am telling, no need to extend further, you will be wasting your time. Now, by chance if they have asked to write it in terms of nanometer, how to do? Any one of you? In terms of nanometer, how much it will be? In terms of nanometer, how much it will be? 9.523. Very good. So who is that? Very good. Stefan. Very good. So now we know that since 1 nanometer is equal to 10 to the power of minus 9 meter. So therefore, by applying this one, for 10 to the power of minus 9 meter, it is 1 nanometer. How much it will be for 9.523 into 10 to the power of minus 8 meter. So meter will get cancelled. It will be in terms of nanometer. So 10 to the power of minus 9, if I take here, it will become plus 9. So naturally it should be plus 9 minus 8. Right? So it will be 1. 10 to the power of 1. So therefore 9.523 into 10 to the power of 1, or we can further simplify it as 95.23 nanometer. 95.23 nanometer. So all of you have understood? Any doubts? Any doubts with regard to this one? Okay, so that's where we have the answer. Please, once again I will tell, you can stop here. For this question, you can stop here. You will get complete marks. This conversion I am teaching, or I am doing it for practice. So that for competitive exams, or if they ask frequency and wavelength in terms of nanometer, if they ask, then you have to solve further. But they will not ask like that, but it will be helpful for your competitive exams. Fine? All of you have understood? Any doubts? So 95.23 nanometer is nothing but UV range. That's why you can cross check your answer. So above 300 and 350, like that, above that it will be visible, and below that it will be UV, and 1 and below 1 and all, it will become X-rays, gamma rays. So until that time it will be UV only. So 95.23 nanometer is nothing but UV region. So that's why we are confirming that it belongs to Lyman series. Fine? Any doubts in this? So this type of problems, even they have asked in your competitive exams also. Okay? So in competitive exams, you can use the shortcuts. Means no need to write each and every step in a rough page. You can skip the steps, but you should not do the mistakes. That's why you should be careful. But for board exam, you have to mention each step. In detail you should write. Because not only final answer will give you the marks, even proper equation, even steps will have the marks. See, for example, due to some calculation problem, you have written wrong answer. They will not give 0 marks to you. Since you have written the proper equation, 1 marks you are going to get. Then since you have written the steps, you are going to get another 1 mark. If it is asked for 3 marks, you will get 2 marks definitely, although final answer is wrong. Okay? So all of you have understood. So in board exam, you have to write each step. Any doubts in this? So hagadre before moving to limitations of Bohr's atomic model, because limitations of Bohr's atomic model you will understand when I will be talking about the concept like de Broglie's equation and Heisenberg's uncertainty principle. Okay, so before going for that, we have to do even these two concepts. So now what I will do is I will give the points for limitations for Bohr's effect or Bohr's atomic model. Then we have to discuss about photoelectric effect, which I have not taught, that is photoelectric effect. So before going to the photoelectric effect, we will discuss about limitations of Bohr's atomic model. So limitations of Bohr's atomic model. Okay, so this is also very important, very important. Depending on the marks, you can decide how many points you have to write. So depending on the marks. Okay, now anyway, so some of the concept, as I told, Heisenberg's uncertainty principle and de Broglie's equation. When I will explain those things, you will understand once again limitations of Bohr's atomic model properly. But for time being, I will give the points. What and all? What are the limitations of Bohr's atomic model? Okay. Now, first one. It is applicable only for. It is applicable. It is applicable only for hydrogen and hydrogen-like species. That is the limitation. Because whatever Bohr's atomic model is there, it is applicable for hydrogen and hydrogen-like species. What are hydrogen-like species? Hydrogen-like species is nothing but isoelectronic species related to hydrogen, like helium plus, lithium plus 2, beryllium plus 3. They are the examples for hydrogen-like species. That should be your first point. That should be your first point. Okay? So all of you have understood? That should be your first point, which is the limitation for Bohr's atomic model. Okay? So next one. Bohr's atomic model, okay, it does not explains the Zeeman effect and Stark effect. Zeeman effect and Stark effect. So hagadre, what do you mean by Zeeman effect? Zeeman effect means splitting of the atomic orbitals. Zeeman effect means splitting of the atomic orbitals in the sense spectra. Splitting of the spectra in the presence of magnetic field. So splitting of spectra in the presence of magnetic field. This is related to Zeeman effect. And when it comes to Stark effect, this is where we have the splitting of spectra in the presence of electric field. In the presence of electric field, this should be Stark effect. So instead of writing those sentences, you can simply write it as it does not explain the splitting of spectra, or it does not explain the Zeeman effect and Stark effect. Okay? No need to write those things. Splitting of spectra in the presence of magnetic field, splitting of the spectra in the presence of electric field. Okay? So that way now is not required. You can simply mention as it does not explain the splitting of spectral region in the presence of magnetic field and electric field, or it does not explain the Zeeman effect and Stark effect. Okay? So that should be your second point. Now, third point here is it does not explain the mechanism of chemical bond formation. It does not explain the chemical bond formation. It does not explain the chemical bond formation. That is another thing. Okay? So it does not explain the chemical bond formation, or you can tell it does not explain the interaction of atoms to form the compound or molecules. Anything is fine. So it does not explain the chemical bond formation, or you can simply mention as it does not explain the interaction of atoms to form the molecule or a compound. Anything is fine. So these are the drawbacks of Bohr's atomic model. Now, next 2 points you will understand when I will be talking about the de Broglie's dual character of electron. Okay, so next one is Heisenberg's uncertainty principle. So once I explain, you will understand last 2 points. Okay, so these are the 3 points where those 2 principles are not applicable. So that's why I have written these 3 first. So next I am going to talk about those points which will be related to Heisenberg's uncertainty principle and de Broglie's equation. All of you have understood? Next point. It considers the only particulate nature of electron. It considers only particulate nature of electron, but not the wave nature of the electron. But not the wave nature of electron. Please remember, don't worry. This one you are going to understand when I will be talking about de Broglie's equation. So what is that? It considers the only particulate nature of electron, but not wave nature of electron, which is based on the de Broglie's equation, which tells that an electron can have particulate character also and it can have the wave character also. Okay, but in case of the Bohr's atomic model, he didn't consider about the wave nature of the electron. He considered only particulate nature of the electron. Okay, so this is based on the de Broglie's equation, which disproves the Bohr's atomic model. Okay, so next one. Bohr's atomic model, he told about a definite path called as orbit. If you recollect, in Bohr's atomic model, the first point itself electrons will be revolving around the nucleus in a definite path called as orbit. If you recollect, that was the first statement. Okay, that one was the first statement, but that is not true. Okay, so it is impossible to calculate the position and momentum of electron simultaneously because it does not have any dimension. Okay, anyway, these things you are going to understand when I will be talking about Heisenberg's uncertainty principle. So what is that? It is impossible to find out position of an electron and momentum of an electron simultaneously. If that is the case, in that case, how we can tell that electrons are moving in that path only? It is not possible. So therefore, according to Heisenberg's principle, it's going to disprove the Bohr's atomic model. Okay, it's going to disprove the Bohr's atomic model. So that's what it considers. Which one? Bohr's atomic model. It considers the definite path, that is orbit, definite path, that is orbit for the electron, which is not possible, according to Heisenberg's principle. According to the Heisenberg's principle. Okay, so that's what these are the points related to limitations of Bohr's atomic model. Okay, so what is that first one? It's applicable only for hydrogen and hydrogen-like species. It's applicable only for hydrogen and hydrogen-like species. Next one, it does not explain the Zeeman effect and Stark effect. You can write like this particular point, or you can mention it as does not explains the, does not, or I have written does not explains the splitting of spectra. It does not explain the splitting of spectra in magnetic field or electric field. Magnetic field or electric field. You can write this one or you can write this one. Does not explains the splitting of spectra in magnetic field or electric field. Even this one can be written, any one of these two, not both. Okay. Next part, it does not explain the chemical bond formation. It does not explain the formation of a molecule. It does not explain the formation of a compound. Anything is fine. So you can write it as it does not explain the chemical bond formation, or it does not explain the formation of a molecule, or it does not explain the formation of a compound. So therefore, or does not explain the formation of a molecule. A general statement. So either you can write this one, it does not explain the chemical bond formation, or you can explain does not explain the formation of a molecule. Anything is fine, any one of these 2 points. All of you have understood? Because for the formation of a molecule, chemical bond has to be formed. Okay. Now next one, it considers the only particulate nature of electron but not the wave nature. Okay, according to de Broglie's principle, which we are going to discuss it later, electron should have 2 character, dual character, that is particulate character and wave character. But in Bohr's atomic model, it does not talk about wave nature of the electron. Okay, that should be our next one. And the last one, it considers the definite path for the electron, that is orbit. According to Bohr's atomic model, it considers the definite path for the electron, which is called as orbit, but which is not possible according to Heisenberg's principle. Okay? So according to Heisenberg's principle, for an electron we cannot tell that this is the path where electron is present. It is impossible. But Bohr's atomic model is contradicted Heisenberg's principle. All of you have understood? So these are some of the limitations of Bohr's atomic model. So depending on the mass, you should decide how many points you are going to write. But it should not be less. If it is asked for 2 marks, 2 points, any of these 2 points you can write. If it is asked for 3, only 3 points you can write or more than 3. It's up to you, but not less than 3. If it is asked for 4, it should be 4, minimum 4, not less than 4. Okay? All of you have understood? Fine. So that's where we have the limitations of Bohr's atomic model. Okay. Before going to the de Broglie's equation and Heisenberg's uncertainty principle, we will discuss about photoelectric effect, which is also very important. We are going to discuss about the photoelectric effect. Okay. So that's where we have important point, concept, not very advanced, but important. Okay. So that is nothing but photoelectric effect. Photoelectric effect. So hagadre, what do you mean by photoelectric effect? See, for example, we will have a metal sheet. We will have a metal sheet. This is a metal sheet. Okay. Now, this metal sheet, it will be exposed to a radiation. It will be exposed to a radiation, H nu. That means energy. A particular frequency of radiation, it will be exposed. See, for example, we have H nu 1. That is one type of radiation for which this metal was exposed. Now, during that time, we cannot observe any movement of the electron from the metal sheet. Something related to light and electricity. We are going to discuss that one. What is exactly it means. Okay. Now, when I will put another radiation, that is H nu naught. And I will put another radiation, that is H nu naught. I will disconnect this and I will be exposing this metal sheet to another radiation. Okay. Now they have observed there will be ejection of electrons from the metal surface. So there will be ejection of electrons from the metal surface. Okay. So that's what it will have. So in earlier case, what is happening? We have H nu. So same principle, it will be utilized in solar panels. Okay, to conduct the electricity, where solar energy will be utilized. Okay, now, so same thing applicable here, but there it will be semiconductors which will be used. Here I am talking about just a metal sheet. Okay, now what is happening here? We have one radiation with frequency of nu 1. Okay, so when it is falling on the metal surface, nothing, no ejection of electron we can observe. But when the same metal sheet is exposed to H nu naught, another energy radiation, now we can see there is an ejection of electron. Now it clearly tells that H nu 1 should be less than that of the H nu 2. H nu 1 is less than that of the H nu 2. Or if I want to tell in terms of energy, because E is equal to H nu, so therefore E1 is less than that of the E2. E1 is less than that of the E2. Okay. So now what I mean to tell here is each metal sheet, photoelectric cells, yes, absolutely correct. Okay, so and where it will be having semiconductors. So but it will be on same principle. Okay, when it will be exposed to solar energy, there will be movement of electrons will takes place, and that's how electricity will be generated. Okay, so now anyway, we are not going detail because you are going to study about semiconductors in your second PU solution topic. Okay, or you might be discussing that one in physics also. So now what I mean to tell you is this particular metal sheet, when it is exposed to H nu 1, there is no movement of electron, no ejection of electron. But when it is exposed to H nu 2, then there is a ejection of electron. This is metal sheet 1. Okay. So I will have another metal sheet of different metal. Okay. So of different metal. So I will call it as metal sheet 2. Okay, which will be of different metals. Now when it is exposed to H nu 1, same energy radiation, in that only there will be ejection of electron. So what it indicates, what you can understand. So this is made up of X metal, that is metal sheet 1. When it is exposed to H nu 1, no ejection of electron. But when it is exposed to H nu 2, there is a ejection of electron. When metal sheet 2, which is made up of Y metal, okay. Now when it is exposed to H nu 1, then only there will be ejection of electron. No need to go for much more higher energy. With H nu 1 only, there will be ejection of electrons. What you can understand by this particular observation? So we can tell that it's not possible for you to type so many sentences. So that's why I am only telling. Okay. So by these two observations we can tell that each metal, which is going to decide a type of metal present in it, type of elements present. So each metal, they require their own amount of frequency of radiation. Listen to me carefully. Each metal, depending on the type of element by which they are made up of, each metal, they will be requiring a definite or amount of radiation for the ejection of electron. It cannot be common. For sodium metal, some amount of radiation to show the ejection of electron. For copper, some amount of radiation which cannot be same as that of the sodium to eject the electron. So that's what we can understand from this particular statement. All of you have understood? Any doubts? All of you have understood this point, what I have told? So what I mean to tell here is, each metal, it demands their own frequency of radiation to have the ejection of electron. And this phenomena is called as photoelectric effect. This phenomena is nothing but photoelectric effect. So in that case, what do you mean by photoelectric effect? So photoelectric effect, yes, I will explain, children. So what do you mean by photoelectric effect? Photoelectric effect is a process where there will be ejection of electrons. There will be ejection of electrons. Yes, Stephen. So there will be ejection of electron from the surface of the metal when they are exposed to energy radiations or when they are exposed to energy. Now you may think, sir, only radiation we can do this? No, that can be in the form of heat. Anything is fine. Okay, I will explain it once again, don't worry. So what I mean to tell you is photoelectric effect. So what I mean to tell you is it is a process. It is a process of ejection of electron. Ejection of electron from the metal surface. From the metal surface when they are, which one? Metal surface. When they are exposed to, if they are exposed to a particular frequency of radiation, a particular frequency of radiation, a particular frequency of radiation. All of you are understanding? So what do you mean by photoelectric effect? It is a process of ejection of electron from the metal surface when they are exposed to, which one they are means metal surface, when they are exposed to particular frequency of radiation. That's what we can give the statement. Definition for photoelectric effect. All of you have understood? Okay? So now I will tell, now I will explain. In this case, metal sheet 1, it is more than enough. Metal sheet 1, it demands H nu 2, this frequency of radiation, then only it will show the photoelectric effect. But when H nu 1 is exposed, it will not show the photoelectric effect. Which one? Metal sheet 1. So where H nu 1 is less than that of the H nu 2, that is nothing but energy of radiation 1 is less than that of the energy of radiation 2, because E is equal to H nu, right? So that's where with respect to metal sheet 1. But when I am coming to metal sheet 2, here even with H nu 1 radiation only, that means even with energy 1 only, there can be emission of electron will takes place, or rejection of electrons will take place. So based on this I can tell that each metal demands a particular frequency of radiation, a particular frequency of radiation to show the photoelectric effect. Each metal, they will require their own frequency of radiation to show the photoelectric effect. So now here Stephen has written, yes, anything less than that, it cannot show the photoelectric effect. A minimum frequency, above that, yes, it will show the photoelectric effect, but less than that, it will not show the photoelectric effect. All of you have got my point? So that minimum frequency of radiation depends on the nature of the metal. It will be depending on the nature of the metal. Each metal, they require their own minimum energy of radiation to show the photoelectric effect. Now whether I am clear? All of you have understood? So try to understand this one. Even this is bit important. May not be that of Bohr's atomic model, hydrogen spectra and all, but bit important only. Even for your competitive exams. Fine. So ಹಾಗಾದ್ರೆ I told minimum frequency, I am telling from that, right? So that's where another word is there, which is called as threshold frequency. Another word is threshold frequency, nu naught. Threshold frequency, nu naught. So ಹಾಗಾದ್ರೆ what do you mean by threshold frequency? Threshold frequency is nothing but minimum frequency of radiation. Minimum frequency of radiation which can show the photoelectric effect. Photoelectric effect by a metal sheet or metal, anything is fine. So what do you mean by threshold frequency? Threshold frequency is minimum frequency of radiation which can show the photoelectric effect by a metal sheet. That is called as threshold frequency. Okay? So anything above the threshold frequency, definitely it will have the photoelectric effect. Anything above the threshold frequency, definitely there will be photoelectric effect. But anything below the threshold frequency, no photoelectric effect can be observed. All of you have understood? So anything above threshold frequency, definitely it will have the photoelectric effect. But anything below the threshold frequency cannot show the photoelectric effect. So below threshold frequency, below the threshold frequency, below the threshold frequency, no photoelectric effect. No photoelectric effect. Now you got the point. So please, since lack of space, I am really sorry. So I have written that side. Okay. So below the threshold frequency, no photoelectric effect can be observed. Okay. But at threshold frequency and above threshold frequency, we can observe the photoelectric effect. All of you have understood? Any doubts in this? Whether I am clear? So any doubts? So this word has to come. Yes, Pooja. This word has to come. Minimum. If you want to define the threshold frequency for a metal, you have to write minimum. That word should be there. That's where we are dealing with the science. In the science, when you are writing the answer, no one will see the grammars. Definitely, no one is worried about your English grammar. But some of the word will have the weightage. Some of the words will have the weightage. That word if you utilize, you are going to get the marks. That's where we are dealing with the science. So proper or appropriate word has to be written. Okay? So done. So what I will do is, I will stop here. So on Friday in my class, we are going to continue with the photoelectric effect, and we will solve one or two problems related to photoelectric effect, which will help you in your exams, even for competitive exams. Okay, so I am not Pooja, Rashmita sir. Okay, but on your this one it was written as Pooja as Pooja. Okay, I am really sorry. Okay, so once again I will tell. Same thing happened with others also. I will be telling some name which is there on the screen. But if you tell me your name also, I will forget about. Okay, definitely I will be forget. So therefore, if I am write one student, he will be writing his name daily. I have forgotten. Andani, he is be writing his name daily, so that I can recollect his name. Okay, I am really sorry for that. Many times I have tried, not only from you people, even from other college students, means for MSc and all, even those students will be complaining the same. Sir, you don't know my name. That's what their expression will be. Okay? So I am really sorry. But I think when I will be facing you, when we will be having offline class, definitely I will be remembering your names. Okay? Thank you. Any doubts? Okay. Thank you. Yes, Dikshit. Now see, morning also he wrote Dikshit Kumar while telling good morning. Once again he is telling. I am really sorry. Okay? So thank you very much. But I think offline class, when we will be having interaction directly, definitely I will remember. Fine? Okay. Thank you everyone.